we'll use the Keyfactor PQC lab that you can get for free from the Azure Marketplace for this demo. You have to approve some terms and conditions and continue. And then to set up an instance like this in Azure, you need to have privileges to build your organization's Azure account, which, well, we build by 0, but you still need the privileges. So you can, if you don't have access, you can request approval from an administrator that has. Once that is done and you have approved, it will be set up in the background for you. So it will set up an EJBCA with a management CA and with some post-quantum CAs. But we will not use these, but instead we will set up new hybrid CAs. Once the instance is done, you have to download a administration client certificate to your browser in order to access the administration GUI. So you click through the browser warning, which is a good thing. This is a private PKI, not a public PKI, so this is actually more secure if you know what you're doing than a public. We use RSA 2048-bit for this client certificate, which is downloaded, and we will install it in the web browser. This is needed to access the administration UI of EJBCA. So import this newly downloaded P12 file. And with that installed, we can go back to the PQC Lab portal and go to the administration web, where we're asked for the authenticate with the newly downloaded P12. So, to create our hybrid CAs, we first have to create crypto tokens with the keys for the CAs. So first we create a crypto token for the root CA. We have to give it a initial authentication code, which is used for decrypting it when it's loaded from the database. And then we can create the keys. So we will use EC ML-DSA for this hybrid CA. So the root CA will use EC P521, which is a good security level for a root CA. It also needs a test key, which uses the same algorithm as this classic algorithm, but it can be faster. So we use P256 since it's only used to test availability of the crypto token. Since if it would have been an HSM, it could have gone offline, for example. Also, default key is needed for some internal purposes, will actually not be used in this setup, but it's needed anyway. And as it's a hybrid CA, we will also create an ML-DSA key. So for a root CA, ML-DSA 87 is a security level matching ECP251. And for the sub CA, we'll do exactly the same. Just speed it up a little bit. So that's done. Now we can create certificate profiles for the root and sub hybrid CAs. So the PQC lab comes with some pre-generated CA certificate profiles, which just sets up how the certificates look like. So we can clone those since they are pretty decently set up. So clone those for the new hybrid CAs, and then we'll go into the details. So for the root CA, we will select to only allow ECDSA and P251. And the signature algorithm will be the matching SHA-512 with ECDSA. We will use an alternative signature since this is a hybrid. And we'll use ML-DSA 87, which has the same name for both the key and the signature algorithm. So we can save that. For the sub-CA certificate profile, we use the same thing, but matching the sub-CA's keys, which is P384, which we created, and ML-DSA 65, which is the matching post-quantum algorithm. We will use the signature algorithm actually inherit from the issuing CA, since it's the root CA that will create the signature on the sub-CA's certificate. So now we have certificate profiles, and we can go on to create our CAs. Starting with the root CA, we will select our newly created crypto token, the hybrid root. We will select the appropriate signature algorithm, the classic signature algorithm, SHA-200-512 with EJBCA, and we will activate hybrid by selecting the ML-DSA 87 as the alternative signature algorithm. It's nice, it selects, pre-selects the correct keys for us. We'll give it a good subject D and the CA, and we'll use our hybrid ML-DSA root CA certificate profile. And that's fine. We can configure some other parameters as well, which we see fit, like the CRL period in that case, set to 1 year. We want to actually have very production-like setup here, so we will create links for the CRL distribution point, which will be set on certificates issued by this root CA. We will also copy the link for the CA issuer URI, which will be put in the certificate issued by this root CA, which will be the sub CA certificate. So we'll do the same, creating the sub CA, selecting all the keys, setting some parameters, and we will also edit the sub CA with these things, including an OCSP responder. So now actually our CA certificates are created. So we create profiles now for hybrid TLS and SMIME certificates. So from our hybrid sub CA, we will issue a hybrid TLS certificate and actually an SMIME encryption certificate to see a couple of different usages. So the TLS certificate will be a hybrid certificate. Signature algorithm will be from the sub CA, defines that it is, but we can set the profile to only allow ML-DSA 44 for the key used in the TLS certificate. We can use the modern 47-day validity period for TLS certificates, and it will only use digital signature and server authentication as key usages. So we save that hybrid TLS profile. And we'll clone the ML-DSA authentication profile to create a hybrid SMIME encryption profile. So we edit that. It will use a ML-KEM 768 as the key algorithm. Signature algorithm will still be inherit from issuing CA, since it's a sub CA who actually creates a signature. We will use 1 year for the encryption certificate and set the key usage for key encipherment, which is the proper one for ML-KEM keys, and extended key usage as email protection. So we can save that. Now we have our profile set up. So now we can actually edit an end entity profile as well to so we can create our end entities. So we'll create an end entity profile for hybrid TLS server. And we'll create a profile for hybrid SMIME encryption. So for the SMIME one, we will use CMP in a specific mode, which will require usage of batch enrollment or clear text encrypted keys. We'll change parameters or values for the country or organization unit. We'll keep the country as ZZ as for testing. SMIME certificate will have an email address in the certificate, which will be required for SMIME. And we will set to use the hybrid SMIME certificate profile. And of course issued by our hybrid sub CA. user generated will be the only default token, so we will use client generated keys. We'll do something similar on the hybrid TLS server end entry profile. It looks good. We will change organization for this Tech Days 2025 lab. It's already set good. The DNS names is what we want for a TLS server. We will change certificate profile to hybrid TLS server, 47-day validity, and the issuing CA, of course, for a hybrid sub CA. That's fine. We can save that. We will also create, since we will issue the CMP certificate from CMP, the SMIME certificate from CMP, we will create a CMP alias for this, where we set some standard CMP settings. The hybrid roots are there for we set the default CA to be the hybrid sub CA, and that should be fine. So to issue certificate, we will want the EJBCA command line interface, which we can download from the PQC lab portal as well. We see the EJBCA CLI, so we unzip it. So we want to generate a hybrid CSR for our TLS certificate. So the EJBCA have a gen CSR command that allows us to do that, to specify a classic and an alternative algorithm keys and algorithms. So there's a lot of help there when you run the command with --help. So we will create a directory and create this hybrid CSR, which we will use to issue the TLS hybrid certificate. So it created a CSR request there. So we'll copy that actually, then we can easily paste it into the RA web of EJBCA to issue the certificate. We say enroll, use username. Hybrid TLS server provided by the user, which is our CRR. If I upload a CSR, we can see it's a hybrid CSR, and it has a good DNS name as common name, which is strictly not required according to CABForum rules, but it's allowed. It has the proper DNS name as an alt name, and we can give the same username. And then we can download the PEM full chain, and everything has been created in EJBCA for us, and the certificate issued and downloaded. So we can look at this with our PKI admin's favorite tool, OpenSSL X509, to see all the nitty-gritty details of the certificate. So if we look at that, you see this, it's signed by, had the classic signature with ECDSA and a classic key. ECDSA, it has all the populated good certificate fields like serial distribution point, and it has the hybrid extensions of the hybrid certificate, both a key, a signature algorithm, and a signature, where the signature is set by the CA and the public key though belongs to the TLS server. So that looks great. For our CMP encryption test, we add an end entity, pre-add one. We call this one my Kushner, tribute to our architect for EJBCA. We set a password and an email. So that's a good few fields for a user. And it looks good that it will be generated from the Hybrid Sub CA. So now we want to use a CMP client, which is another command line tool available in EJBCA. Issuing a ML-KEM keys is very special, so you can see it says added pop of type 2 anchor cert. That means that the request was sent requesting the CA to send back the certificate encrypted, and you can also see there decrypting return certificate with private key of type ML-DSA ML-KEM 768. And we can look at the certificate again with OpenSSL. So we see that now OpenSSL is unable to load the public key because it's an ML-KEM public key. And we're using OpenSSL in a version less than 3.5. OpenSSL 3.5 added support for ML-DSA and ML-KEM. So thank you.